Video we're going to talk about interpolation. It's based on what we did in predicting the range. So the first thing that we want to do is we want to make ourselves a new Excel spreadsheet based on that. So let's just duplicate what we have here. I'm just going to go up to duplicate, and you want to have this in the appropriate folder. You may not have it there now, but make sure you go to Dropbox, make a folder, call it interpolation, and then put it in, or just have a more general folder. So let's just go ahead and say interpolation. Interpolation. So I'm just going to go ahead and save that. Now this is interpolation. Interpolation is when you have 2 points. We have 0 and 20, and we have 2 predicted ranges here. Okay, so at 0 degrees it's going to land at 0.4 meters if we round it up, and then it'll land at 0.85 meters or 0.9 meters at 20 degrees. So we verified these 2 points, okay, here at 0.39 and 0.83 to from 0 to 0, a 0% error to a 1.6. This is really good since the manufacturer actually specifies that the mini launcher that we're using is accurate, or it has a precision, not accurate, but let's say it has a precision to its accuracy to within 5%. Cool. Hopefully that's clear. Okay, so now what we want to do is, since we've made this interpolation document, let's go ahead and take predicting the range. Not like that. Let's do it once. Let's tap it once. Okay, so I just tap down here once, and I want to duplicate that page, and we're going to call this interpolation. Interpolation. So since this is pretty much the 4th page, I'm just going to pull it to the right here. Okay. So now that we have interpolation, what we want to do is we want to insert 19 rows in between here. Okay, because we want to go from 0 to 19. To 20. So in increments of 1, we want to go 0, 1, 2, 3, 4. So that's us changing our angle. The angle is going to be 0 degrees, and then 1 degrees. And so what's the importance in doing interpolation? Well, we're not physically doing these experiments. All we're doing are calculations. Okay, this is something that we can do on a computer. You don't have to take a lot of time. It's something on and on and on. I could tell you all of the monetary benefits, but still. So let's go ahead and insert 2 more, and then that's 2. Let's insert more. That's 4. So we have 8 here, insert above, so that's 16. So let me grab 4 more, and I think that'll be 20. Insert above. So the way we'll be able to verify that is by doing this. We'll just say 1, 2, 3. Okay. And so this is at an angle 0 degrees, 1 degrees, 2 degrees, 3 degrees. I'll just fill that and drag that down to right above 20. Okay, I'm going to stop right there. So what do you see there? We have 2 angles for 20 degrees. So actually I put in too many rows. So let me go ahead and delete this. Now we have from 0 to 20 degrees in increments of 1. So now the initial velocity for each one of these will be the same all the way down. All right, so I'm just going to go ahead and grab that initial velocity. It's not going to change coming out of the mini launcher, but what goes in the x direction and what goes in the y direction will. The amount of velocity, the amount of initial velocity that's contributed to the x direction and contributed to the y direction is going to change. It's just like throwing a football straight out or throwing it at an angle, okay? So let's go ahead and fill. So I'll just drag this down. It shouldn't be any kind of calculation. So all of these should be the same number. And then now remember that our angle in radians is a calculation. And so what we're going to do is we're just going to drag that down. I'm going to select our fill and drag down. Okay, so notice that the very last number here, 0.33, is not greater than 0.34. That's important to see. And then we'll do the same thing for A. A should be the same thing. So I'm just going to drag this down. Okay, so you'll see that it's the same all the way down. It doesn't change because A is only dependent on gravity, and gravity is 9.81. So A is 1/2 of a negative 9.81. Thus, we have a negative 4.905. So B is actually a calculation that's based on the initial velocity and the angle. So on this yellow and green, so I can just go ahead and fill that. Let's drag this down. Now that number should not go above 1.03. The initial velocity in the y direction, it should not go above that. And you can see that it's not. So that's further verification. So now what we need to calculate our time of flight, but our time of flight is based on what we have in the y direction, our y displacement. So what's happening is our angle is changing as the y direction changes. No, I'm sorry, the y direction is changing as the angle changes. So what we need to do is we need to increment. This is where we are making an assumption that our angle and our height is 1-to-1. Okay, so let's go ahead and do that. Let's insert a new column, and let's say that this is going to be a calculation. So let's call this increments. All right, and it's going to be measured in meters, just to make it clear on what this is. So our increments are going to be equals to, and let me pull this up, it's going to be equals to our height at 20 degrees minus our height at 0 degrees. All right, so we need to put that into a parenthetical statement. And then we're going to divide this by 20. Okay? So basically, this 0.0023, that's 2.3 millimeters. So we're saying that for every degree, the mini launcher is going to rise 2.3 millimeters. Okay? So what we're going to do is we're going to go ahead and drag this down. But first we need to, because there's only one calculation, we need to reference that cell. And then we need to drag this down. So I'm going to say fill. Okay. So now I'm going to go ahead and make this thing a different color. Green and red, let's go ahead and make it brown. Okay. So now since it's brown, we're just basically saying that it's a measurement and a calculation. It's really an interpolation. So we're going to say this is going to equal to the first measurement at 0 degrees plus. So this is at 1 degree plus its increment. So this plus its increment is going to be the height at 1 degrees. Okay? And so it makes sense that it gets a little bit larger. Again, this is an interpolating. So we're going to do that all the way down. Just going to say fill. And we're going to fill right up to right before 12. Now the value right before 0.1289775 should not go over that. If it does, there's something wrong with our calculation. So I'm going to release now. And indeed, it is not greater than. So now that we have our heights, we can calculate our time of flight as well as our predicted range. So there's no need for us to wait on this. I can fill and grab both of them, pull down. And notice that at the bottom, 0.299 for the time is greater than 0.29, and 0.85 is greater than 0.83. Okay, so this is what we would call interpolated. This is our predicted range right here in meters, and all of these values in between 0 and 20 are interpolated. Now what I do want you to do is I want you to have a graph for this. So we're going to go over and grab our angles. I'm just going to copy that. I'm not going to delete it. Some things are dependent on it. And then I'm going to insert on the left. Okay. So when I insert on the left, I want to grab both of these. And I want to go ahead and produce a graph of predicted range and angle in degrees. So the angle in degrees is going to be on the independent axis, and the predicted range is going to be dependent on that. So we're going to insert a chart. All I did was I went from home to insert, and I'm going to go over to chart, and I'm going to pick XY scatter here. I'm going to wait for it to come open, and I'm going to choose scatter right here. And so now you'll see that we have predicted range in meters. Let me just drag this over here so we can see this a little bit better. All right. So I'm going to say interpolating the range versus the angle. And I want to say interpolating the range. That's probably good enough. Interpolating the range. All right, so we have interpolating the range, and typically this is going to be capitalized. Interpolating the range, and we need to label our axis, okay? So our axis, and we need to know what's on the horizontal axis. The angles are on the horizontal axis. So let's go ahead and add those. Excuse me. So we have angle in degrees on the horizontal axis. And then for our y-axis, it's our vertical axis, really. Shouldn't call it y, I should call it vertical. This is going to be the range in meters, or the x displacement. All right. And basically that would pretty much complete this project, but I want you to see how to interpret this. We only measured what was happening at 0 degrees and 20 degrees. Now, if we want to, we can go in and find out what's going to happen at 5 degrees. At 5 degrees, it should land a little bit beyond 0.5 meters. At 10 degrees, it should land a little bit more than 6.2 meters. At 15 degrees, it's around 7.5. So that's the benefit of doing this. We didn't have to do any more experimentation or anything like that. So this would be our interpolated values. I probably will put a video up there for you guys to verify this, but later, not for this one. Okay?